Welcome to the chapter on electric and magnetic fields. These fundamental concepts are essential for understanding how electrical devices operate and the forces that charged particles exert on each other. Atoms are the basic building blocks of matter. They consist of a nucleus containing protons and neutrons, surrounded by electrons. Protons are positively charged particles found in the nucleus, while electrons are negatively charged particles that orbit the nucleus. Neutrons are neutral particles found in the nucleus. The charge of a proton is approximately positive 1.602 times 10 to the power of negative 19 coulombs, while the charge of an electron is approximately negative 1.602 times 10 to the power of negative 19 coulombs. Materials conduct electricity when they allow electrons to move freely through them. Conductors, such as metals, have free electrons that can move easily. Insulators, like rubber, do not have free electrons and thus do not conduct electricity well. An electric field, or E field, is a region around a charged particle where a force would be exerted on other charged particles. The electric field E at a point in space is defined as the electric force F per unit charge Q. The formula is E equals F divided by Q. Electric fields are represented by field lines. These lines start on positive charges and end on negative charges. The density of the lines indicates the strength of the field. The force F experienced by a charge Q in an electric field E is given by the formula F equals Q times E. This means that the force on a charge is directly proportional to the magnitude of the charge and the electric field. Electric potential, denoted as V, at a point is the work done to move a unit positive charge from infinity to that point. Voltage is the difference in electric potential between 2 points. The relationship between electric potential and electric field is given by the formula V equals negative integral of E dot dl. Electric current, denoted as I, is the flow of electric charge. It is measured in amperes. The current is given by the formula I equals dq divided by dt, where dq is the charge passing through a point in time dt. There are two ways to describe the direction of current. Technical current direction refers to the flow of positive charge from positive to negative. Physical current direction refers to the actual flow of electrons, which is from negative to positive. A magnetic field, or B field, is a region where a magnetic force is exerted on moving charges. The magnetic field is measured in teslas. Elementary magnets are small regions within a material where the magnetic moments of atoms are aligned. These regions can align with an external magnetic field, causing the material to become magnetized. Magnetic fields are represented by field lines. These lines form closed loops, starting and ending on magnetic poles. The density of the lines indicates the strength of the field. Electromagnetism is the interaction between electric and magnetic fields. A changing electric field generates a magnetic field, and a changing magnetic field generates an electric field. Faraday's law of induction states that a changing magnetic field within a closed loop induces an electromotive force, or EMF, in the loop. The formula is EMF equals negative d phi b divided by dt, where phi b is the magnetic flux. Magnetic flux, denoted as phi b, through a surface is the product of the magnetic field B and the area A it penetrates. The formula is phi b equals b dot A. Lenz's law states that the direction of the induced EMF and current will oppose the change in magnetic flux that caused them. The Lorentz force is the force experienced by a charged particle moving in an electric and magnetic field. The formula is F equals Q times the sum of E and V cross B, where V is the velocity of the particle. The right-hand rule, or three-finger rule, helps determine the direction of the force on a positive charge moving in a magnetic field. Point your thumb in the direction of velocity, your index finger in the direction of the magnetic field, and your middle finger will point in the direction of the force. To summarize, electric fields, or E fields, are created by charges and exert force on charges. Magnetic fields, or B fields, are created by moving charges or changing electric fields and exert force on moving charges. Understanding these fields and their interactions is crucial for analyzing and designing electrical systems. This concludes our chapter on electric and magnetic fields. Thank you for watching, and we hope you now have a better understanding of these fundamental concepts in electrical engineering.